Here we are solving a separable differential equation for which we will be able to find the particular solution due to an initial condition that is given to us. We are asked to solve the differential equation dy dx equals negative 1/2 y if the point 0, 10 is known to lie on the graph of the original function. We start out, as we always do, in separating our variables, the x's and the y's, to the left and to the right. If I begin by multiplying both sides by dx, I now can divide both sides by y. I would recommend keeping the constant there with the dx. It simply comes out easier in the end. Now that my y's and my x's are separated to the two sides of the equation, I go ahead and take the antiderivative of both sides of the equation. Finding the antiderivative, on the left I have natural log absolute value of y. On the right side, I have negative 1/2 x plus c. As we have seen in other examples, that's the end of the calculus, and here on out we employ some algebra, specifically the definition of a natural log in terms of an exponential equation in terms of e, to rewrite what we have. Therefore, we would have e raised to the negative 1/2 x plus c is equal to absolute value of y. I'm going to continue to rewrite this on the left side of the equal sign. E to the c, once we were to split up this left side according to the laws of exponents, I can rewrite that as a separate constant. I'm going to use k. You can use whichever variable you wish. That leaves me with absolute value of y equals k times e raised to the negative 1/2 x. Now remember, we were told the point 0, 10 lies on the original curve, so I can substitute that in place of my y's and x's so as to be able to solve for my k value. I then would have that 10 is equal to k times e. In the exponent I then have 0. E to the 0 of course is 1, so I find that k is equal to 10. What that means then in the end is y is equal to 10 times e raised to the negative 1/2 x. The reason I can eliminate the absolute value bars is no matter what x I were to have, I would always end up with a positive y value. E to the negative 1/2 x is always going to be positive, multiplied then by a positive 10 would yield a positive y value. This then becomes the particular solution to my differential equation.